All right, so let's chat about Numa. SQL Server is smart about Numa. Numa stands for non-uniform memory architecture. And by non-uniform, our hardware may have more than one processor bank is what we're generally talking about here. So in this diagram, the way that physical hardware has evolved, this isn't always true, but a lot of servers these days are true. This sort of started at maybe 10, 15 years ago, and it's become more and more common for hardware to have different CPU banks that have memory that can be quickly accessed from that CPU bank. So these birdhouses represent physical CPUs, which may have multiple logical cores. These guys represent the logical cores. Maybe we have hyperthreading, maybe we don't. But that physical CPU bank, this is picturing a two-socket server. Each socket has memory that is very fast to access from that socket because it is really closely tied into those physical cores in that socket. Now, this socket can access memory in the other socket, but oftentimes it is slower for these cores to go access memory that's in another socket than it is for the cores to access memory that is local to that socket. The SQL Server OS is Numa aware. When SQL Server starts up, it looks at how many sockets do I see? How many Numa nodes do I see? These are referred to as Numa nodes. How many of them do I see and how much memory is associated with them? The SQL Server OS wants to do this for performance because it knows that accessing, depending on what data I'm accessing, if I can store related data in a given Numa node and just have a set of processors access local data there, that's going to be faster than for one query putting some of the data over here and some of the data over here and then having cores access remote data. It does its best to, when it can, based on the amount of memory and the cores you're using. So our max stop determines how many cores we're using, right? That will help us help SQL Server see, can I fit this query? Can I fit the data for your query, for the buffer pool, into the same Numa node that the processors are using? And of course, it can't always be perfect, but this does inform how we test max stop. And things have changed over time. So sometimes now, different hardware is different. Sometimes that remote memory access is much slower. Sometimes it's not. It really can depend on your server. The speed that it is in your virtual machine, there is some overhead for virtualization, but of course the speed that it's going to be in your virtual machine, there's going to be a couple different things that can happen. Can your virtual machine see does it match up with the hypervisor's architecture? Oftentimes these days you can configure your VM to either fit, like maybe this is my server hardware. Oftentimes we could configure a virtual machine so that it fits in just one Numa node on the host. The host may have more than two, but we could size a virtual machine so that its memory as well as its processors fit inside one Numa node. And more, this varies by hypervisor, but more and more the hypervisors are smart about saying, oh, if this VM fits inside this Numa node, I will just have it use that. But sometimes it may span Numa nodes. There's different ways. We're going to talk a little bit more about this, but we generally, if we have a virtual machine, we generally want to either size it so it fits in one of the Numa nodes, or if it doesn't fit in one of the Numa nodes, either because there's just not enough memory, like the VM's memory is bigger than the amount of memory in one Numa node, or because the VM is using more cores than are in one Numa node, then we may want to align the VM so that its Numa architecture matches the host architecture. This could be very hard to do if we're in an environment with multiple hosts, and our VM might, maybe it could be on different hosts at the same time. If those hosts have different hardware architecture, if they have different amounts of Numa nodes, different amounts of memory, that can be really tricky, right? Because I really want my VM to align with my host. This is one of the best practices for running SQL Server on virtual hosts, is you really want the hosts to match one another, because I want to make sure I fit on different hosts. Numa is for performance, and we have more Numa tools that have come to us. If you are wondering, hey, for my server, what kind of cores do I have, and is it slow to do remote memory access? Sysinternals, a team at Microsoft, has a tool named Core Info. This is part of the Sysinternals suite. You can download the whole suite, and you can run Core Info on your host on your VM, and it will tell you how many processors do I see, what is the more detail than you can get out of some of just the GUI toolbox diagrams, and it's easy to copy and paste. So this is a very powerful tool to tell you how many Numa nodes are there. You can also see those in other ways, but this is just very convenient. And it will also, sometimes you can have core info if you want to test, make sure it's appropriate to test this, but it can test remote memory access speeds. That can be very, very handy. We have a new type of Numa in SQL Server. We've had the ability for a while, but this was very rarely used. We've had the ability to configure what's called soft Numa for a while. It's easy to mess up. But what soft Numa does, this is different than hardware Numa. Hardware Numa is, I see my physical architecture's Numa nodes. Soft Numa is, I want to make even more groupings. This picture, imagine that this is still two physical sockets. We've still got two birdhouses here. But imagine that what's happened recently is that we have more and more cores per socket. Like we have lots of cores per socket. Notice that we have a lot of different birds here. Right here we have 16 cores per socket. It is difficult. The SQL Server team has found that in terms of scaling very busy systems, if I have a Numa node that has 16 processors in it, there are certain internal shared data structures that it is difficult to coordinate access to. They already had it set up where if like I saw two Numa nodes, I could segment things a little bit. But then they found that on very busy systems, it was very hard to scale beyond 8 cores per Numa node. They just kept running into different challenges there. What automatic soft Numa does is it says, oh, well, I see that you've got 2 physical Numa nodes here, but you've got so many cores that I am going to actually softly, this isn't hardware stuff, but I'm going to divide you up into more groups. And certain internal system processes are scaled at the level of the soft Numa. Now, this sounds really weird and confusing. It's not actually, we'll look at a demo of it. It's not actually that weird and confusing. This only kicks in if you have a certain amount of cores showing. So if you just don't have enough cores, it will not kick in. And the type of things that this solves are things that you're only really going to see in a very high concurrency system, things like spin lock access to shared data structures. It's a logical partitioning, and the Bobs, there are Bob Dorr and Bob Ward at Microsoft, they have helped blog about this a bit. It will kick in at different times at different levels. Oh, and I see over there someone, thank you for, that's another cause. So another cause that a plan will get automatically unforced if the underlying object definition fails. So let's say I have, if with Query Store, let's say I have, I've forced a plan with a given index in it, and then I drop the index. The plan, the forced status still remains there, but it will fail to force the plan. It will just fail. And actually, one cool thing, we have a SQL challenge active this week, where if you want to do a SQL challenge, what it is I've caused a forced plan to fail in Query Store, and your challenge is to set up an extended events challenge or an extended events trace to get more detail. You can see in a DMV that it's failed. It just doesn't give you a lot of detail. So yeah, but the plan does stay forced. And the cool thing is, if you put that index back, if you change the schema back, the forcing will just resume. It will just be like, oh, now I can force it again. We're good again. So that's actually kind of cool. Anyway, so when does automatic soft Numa kick in? If I have 8 or more virtual processors and SQL Server, if it can't tell from the virtual operating system whether or not hyperthreading is enabled, because it just sees like the Windows or the operating system just says, hey, I've got 8 cores, it will turn on. For a physical server where it can correctly see hyperthreading, it will turn on for 8 or more physical cores. So for virtual, it'll look at just your logical processors because that's all it can see. For non-virtual, it will look at physical cores. If we want to implement Numa with virtualization, a big thing, we have to know who our hypervisor is, and we have to know what version of it we're running, because how the hypervisor handles Numa changes a lot. So for example, a recent version of VMware has changed how your virtual machine will create Numa nodes. based on how many, and now it's based on how many CPUs it has. So it says, oh, if your number of CPUs fits within a Numa node on the hardware, I will just size you based on that. It doesn't look at the memory though. What if the memory actually doesn't fit in one node? In that case, you might have to do some special configuration. So with any virtualization, I want to know what version of the what hypervisor am I using and what version is it? I want to go look for their best practices on setting it up and figure out, okay, I need to know for my hosts, what architecture do they have? Hopefully I can get that. If I'm using the cloud, that may even not be available to me. If I'm using the cloud, I may have to go with just whatever I can see in the OS, which is kind of a bummer. But hopefully I can figure out if it is like a private cloud setup, hopefully I can figure out what the host architecture is and make sure that my VM is aligned within the host, because I want my VM, if let's say my host has 2 Numa nodes, 64 cores, it has 32 physical cores, hyper-threading is enabled. So there are 32 logical cores per Numa node, and I've got 520 gigs of memory across both nodes. If my VM has 16 cores and 320 gigs of memory, this doesn't fit inside a single VM, right? Because 320 is more than half of 500, or 320 is more than half of 520. So if it doesn't align, I will want to look at in the VM, look at, okay, how many Numa nodes does Windows see, and see if I can configure it to see 2 Numa nodes, that each of the Numa nodes in the VM can be aligned inside a Numa node in the host. If I can get away with, I mean, maybe the solution, depending on my environment, would be to add more memory to the host so there's more memory per node. I mean, that would be one option too. Sometimes I can't do that, so I need to try to configure things. But how I configure this is going to compare. So let's see, a comment. We also noticed that if you have equal or less than 8, even with 2 sockets, SQL doesn't see 2 Numa nodes. So what's SQL? Oh, is this on physical hardware or virtual? SQL Server, if you're running on physical hardware, okay, this is virtual. If you're running on virtual hardware, the Numa nodes that SQL sees should be just what is presented to it by the operating system. Now, one of the changes here, if you're running on VMware, the change, and I think what you're saying is that so used to with VMware, it would configure Numa nodes just based on how you configured the virtual sockets. That's what's changed in 6.5. Okay, I see what you're saying, is that with your VMware setup, it is configured with multiple sockets, but it's no longer showing the same Numa nodes as the number of virtual sockets, because it's simply looking at the processor count and the host processor counts. Yeah, exactly. So it's getting weird, but I would still go back and look at, okay, with our memory now, is it appropriate that it's seeing only one Numa node, or are we using so much memory that it actually doesn't fit into one of the nodes? Just to make sense, because you want SQL Server to kind of know, the SQL OS to have as much information about the host hardware as possible. So if it's going to have to use more than one node on the host hardware, you want SQL Server to be aware of that ideally. It's tough though. It's getting more and more complicated. Oh my goodness. Okay, so let's take a look at what the automatic Numa looks like in our test environment. This test environment, my host simply has one socket with 6 physical cores per socket and 12 logical processors. Since this is virtual, my VM has no idea about the hyperthreading. It just doesn't know. It just sees its Windows instance with the virtual CPUs, and it's like, well, behind the scenes, that could be anything. So I just see that there's more than 8 of them. You can always tell easily what SQL Server sees by looking at the dynamic management views or the startup log. When SQL Server starts up, it'll tell you how many of these see. Okay, so the question, could you please explain a little bit more about what changes with VMware 6.5? There is some good documentation for this online. The essential change is that when, for a new VM, what it looks at to determine the Numa nodes is it has decoupled. So, okay, let me say this right. So 6.5 decoupled the configuration of the virtual sockets for the VM with the Numa node setup. Instead, it looks at how many cores are you using and how many cores are in a Numa node on the host, which may be good or may be bad. If your memory also fits into one of those Numa nodes on the host, it's fine, right? Because then your VM is just going to align to a single Numa node. If you have cores that fit into one node, but your memory is wider than one node, then it may not be fine. And you may want to you can still override this. You can do a special configuration of your VM and go into advanced properties and be like, no, I actually want this many Numa nodes. So you do have the option for it. This is just kind of the automatic configuration if you don't do the specialized configurations. Comment, I read that to avoid soft Numa, it is better to have one socket and 8 logical cores because anything more than 8 cores, soft Numa kicks in VMware. Is this correct? So I would question that as blanket advice. Let's see. So it is better to have, although I think it's, so if I have one socket and 8 logical cores, so it's getting kind of complicated to answer this question. So just because of the thing I would look at, let's step back a moment. The first thing to look at is whether or not soft Numa is kicking in for your SQL Server instance. Right now, I have soft Numa turned off. You can manually turn this on and off. So one thing to know is, however things are configured in terms of the Numa, you can enable and disable the automatic soft Numa. So you can control that regardless. Right now, I have it turned off. I'll show you how to turn it on and off. In sys.dm/os info, in SQL Server 2008 and higher, some of these things are SQL Server 2017 plus, but I can always see for soft Numa, which is soft Numa is SQL Server 2016 and higher. I can always see if it's on here. For 2017 and higher, I can see my socket count and cores per socket. This is because this column over here, hyperthread ratio, is not very useful. Hyperthread ratio has nothing to do with hyperthreading. We've had this column for a long time, but it's basically just saying, in this case, I see 10 logical processors and there's one socket is what it's trying to say here. It has no idea if hyperthreading is enabled. But right now, I do have software Numa turned off. I can also look at sys.dm/os nodes. Sys.dm/os nodes will tell me how many Numa nodes I have. This will work way back in older versions of SQL Server 2. I think this is 2008 plus. I can see here, if I just have node ID 0 and 64, I have a single Numa node. They start at number 0. So soft Numa is off. It's not adding extra Numa nodes. I have one Numa node. Does anyone know what node ID 64 is? Node ID 64 is the dedicated admin connection. So it's not a real memory node. It's reserved resources. Oh, there you go. So DAC, I kind of answered too fast before people could tap. Yeah, there's little resources held for the dedicated admin connection, just in case you need to connect instead of an emergency. It's always single threaded, but you can, it's a resource that if the SQL Server gets overwhelmed, it is there for you. So I can tell that way how many Numa nodes I have as well. We're going to do right now I have automatic soft Numa turned off. We're going to look at I have a single Numa node. We're going to look at my session ID. I'm session ID 57. So what we're going to do is we're going to test query performance for me with automatic soft Numa off, and then we're going to turn it on and test and see, do we see a performance difference? So I am going to use my database, and while this is running, so what was my session? My session ID is 57. So we're going to copy this query into another session, and I'm going to spy on my query while it's running. So let's start up our query. And it's just running a larger query that dumps table data into foo. And we can see, I'm looking at, while this is running, I'm looking at sys.dm/os tasks and related dynamic management views. And I can see this, I'm running this at .5. I can see that these are all in Numa node 0. Well, that's good because I only have the Numa node 0 and I'm not connected to the DAC. And they are using schedulers 2, 3, 4, 6, 7, and 8. I get 5 CPUs, and these happen to be the ones that it chose. Have a little bit of waiting going on there. My other ones are running, but it's using those CPUs, and it's going to keep using those same CPUs, having different tasks run on and off of them until it completes. But I haven't separated this up into multiple Numa nodes, right? So it just uses any of the processors that it finds out of my 10, right? So now I have a different wait happening over here. It's waiting to pull data into cache. This query, it takes a little while to complete. I don't know that I have some runtimes on this to show you that I've compared behind the scenes. So I don't know that we have to let it complete here. If you want to, you can let it complete. But let's compare what happens when we have soft Numa on. I'm going to change soft Numa on or off. We do have to do a system restart. So it's not something we can do online. I need to change my soft Numa setting. And then if I did have my SQL Server agent running, I need to get down to here's my task. Here it is. If I had the SQL Server agent running, I would need to shut it off. But I don't have my agent service running. The agent will run a kind of reconfigure that'll undo your command. So you essentially have to stop the SQL Server agent, then restart your instance. This is documented in books online. I have a link to it in the slides, but just know that to turn this on and off, read the instructions and make sure to keep the SQL Server agent from foiling your plans. You can also check once you get it back online. We can easily check, do we have this on? I'm going to go back up to the top and look at sysinfo again. Now, soft Numa is turned on. I have one socket. I have 10 cores per socket. It has divided my 10 cores into 2 Numa nodes with 5 cores each. This will change a little bit of how my query runs. Now, notice that CPU count is 10, hyper, that's still the same. That's still the same. When I look at sys.dm OS nodes now, I have node 0 and I have node 1. This actually, so some of my slides earlier, the thread count in the slides showed Numa nodes, and the demo I was showing you didn't show Numa nodes. It's because the screenshots I took in the slides, I had soft Numa on, and the demo I was showing you live, I had soft Numa off. That's why that was a little different there. So here are my 2 Numa nodes. There are 5 CPUs each, and I've got workers on them. I can even see a little bit of how load happens to be balanced between them that the SQL Server OS is doing. Let's see what my SPID is now. It is now SPID 51 because I restarted my instance and reconnected. I'm going to run the exact same large query that populates this table, and we'll just notice what is different about the threads. So looking at how this is running, it has put 5 threads into, now these are threads, right? I am using these 4 CPUs to do the work. These are all in node 0. So all of my threads who are actively retrieving data and dealing with data, they are all on node 0. I do actually have, notice that I actually do have another guy who's on scheduler ID 5, who's in node 1. It is that it's got a CX consumer weight. It's related to that overhead on parallelism. But SQL Server worked hard to localize all of these guys to be inside one of the logical Numa nodes, and they are going to stay on those schedulers there. So I do have a coordinator thread who happens to be in the other node, but everybody who's actually doing data access is within the same Numa node. So that can be super duper useful there. All right, any questions about that one while we're there? All right, let me know if questions on this one come up. So this is actually very interesting in terms of the query performance. I'm going to go ahead and leave auto soft Numa on there, and brain exploding. So we can simplify this a bit. It's actually going to get a little more complicated when we talk about weight stats, but we can simplify this a bit. So here is the big takeaways that I would take away from this. When you're working with a virtual machine, what you really want to know is, okay, how much memory and how many logical cores do I have on this VM? And then for the hosts, how much memory and logical cores do they have per Numa node? And it's hard to get that information. If you can ask someone, hey, do you guys have the core info tool? Are you willing to run that? It will print out information about that. So if we have this example host, what we really want to know is, given my VM, does it fit inside one Numa node on the host? Whenever it can fit inside one Numa node, I would just say, oh, that's great. We're going to fit inside one Numa node. And then it's fine for the VM to present just one Numa node to the SQL Server. Totally fine. Generally, for one thing you may need to think about sometimes when it comes to configuring sockets and cores, if you are running SQL Server Standard Edition, SQL Server Standard Edition is limited to the number of sockets you can use. Like, you are licensed up to, I think it's 4 sockets, right? So if you're using Standard Edition, you definitely do not want to create your VM with 8 sockets, 1 core each, because right then your SQL Server would be like, oh, I can't use all these. I'm not licensed for it. So you do want to think about your SQL Server Edition when it comes to configuring that host. That's part of what goes into the socket alignment. You also want to know what version is your hypervisor if you're seeing that it is, creating a VM that has more memory than will fit into one Numa node and is only showing one Numa node. Yeah, it's lots of fun, and it's getting more and more fun. I have generally found in my testing that automatic soft Numa doesn't make much impact on individual query operation for me at all. The benefits of soft Numa, and this is the bit about the restart options where you need to stop the SQL Server agent, then configure soft Numa, then restart the instance. That's where that's documented there. But generally, what soft Numa helps with is if I have a ton of concurrent queries, accessing shared data structures is really what it helps with. So to automatic soft Numa, I don't tend to see that it slows my query down or speeds my query up if I'm running it in isolation, which is good. Another thing with soft Numa that we'll see is that you don't necessarily want the soft Numa to guide your max stop, which I believe sounds weird, but we'll look at it here.